Alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about a simple dynamic programming problem, Decode ways. Its index is 91 and it is a medium type problem of the LeetCode. Okay, so this problem is like a simpler version of its harder problem. You can find a series of problems on this name, Decode ways. You can go to the bottom section of this problem description. You are going to find a similar question section. You can see a decode ways second part. So if you click over there, then you are going to find this hard problem, which is actually the modification of the very first problem that I'm going to discuss it right now. Okay, so you can see over here, actually I have solved this problem already, and actually I have provided the video explanation also present over my channel. And the difference between this second problem of decode ways and the first problem is like I will tell that while I will explaining this one. For now, let's give a short description. Is that every position, like for a encoded message, there can be an asterisk present over here, and we have to return the answer modulo with this prime number. The answer is going to be like very much large. You can see a string can also contain asterisks, and it can be any character. Okay, we are going to account for all those possible decodings. Okay, so I'm not going to discuss this in detail, but I will suggest you to solve this problem. And like because this is the like base, this problem is totally based on the basics of dynamic programming. You need to identify the states, different states that need to be covered. And if you are stuck upon this problem, then I will say that go over to the net and search code with second. You're going to find the video over here, the very first video you can see over here, decode ways to dynamic programming, and it is based on strings and everything I have discussed over here. So you will feel ease if you are if you are stuck upon and you're going to watch this video, and that's all. Means that you are going to solve this problem and understand the concepts where like everything would be cleared. Okay, so without wasting our time on all these stuffs, let's discuss this problem. So we would be given a message containing the letters from A to Z can be encoded into the numbers using the following mapping. Okay, so and you can see the character A is going to be mapped with 1, character B has the mapping as 2, and similarly it goes on to the character Z, it has the mapping as 26. Okay, now to decode an encoded message, all the digits must be grouped together and then mapped back into the letters using the reverse of the mapping above. Okay, there may be the multiple ways obviously, because you can see that if we have the character like let's say 26, let's say you can group them as like 2, or you can group them as like 6. This is one of the possible way. Also you are going to group 26 as it is, because Z is going to be denoted by this 26. So this is Z, and this is like 2 is going to be denoted by B, and 6 is going to be denoted like A, B, C, D, E, F. So you can see that it is like BF. Okay, so 26 is going to be denoted by Z, and if you group them like that, it is like BF. Okay, so there are two possible ways as I have discussed. So you need to group them, like you need to separate the digits such that it is a valid grouping, valid mappings. Okay, you can see over here there is an example given 11106. You can group them as like 1 separately, 1 then followed by 10 and 6. You can see that every group like 1, 1, 10 and 6 is a valid mapping. 1 is for A, 1 is for A, and 10 is for J, and 6 is for F. There can exist multiple mappings, as over here you can see that 111106 is actually have two mappings. There can be multiple mappings, AAJF and KJF. You can see over here. If you are not understanding this problem till right now, no need to worry about. I am going to explain this in detail while we are just understanding this problem entirely with the help of examples and approaching the solutions. Okay. Now note that okay, so 06 is an invalid grouping also, because you cannot have a character like this one. We are going to have a if we are going to fetch the sixth, then you are going to write 6 directly, not 06. So this is not a valid mapping into F. Okay. Now we'll be given a string S, which would be consisting of only the digits. You can see over here. Return the number of ways to decode it, number of ways to put out the brackets in between. As I have said, like you're going to separate the digits, and it is a valid mapping also. Like every group should be a valid mapping also. Okay, the answer is guaranteed to be fit into 32-bit integer. Okay, so answer is not going to overflow. Okay, so let's discuss this problem with the help of examples, and then we together build up the best solution for this problem. So let's move further. Okay, so let's take an example and let's understand how the given encoded message can be decoded with a like valid mappings. Suppose we have the strings like 2 to 6. Okay, so this is a string and we need to identify all the valid like valid message that can be formed with this one. You can see that I can have like I can group this 2 into this one separate one, and I can group this 2 into a separate one. I can group this 6 into the separate one. Okay, so this is one of the valid mappings. If you convert every group into a suitable character format, you can see that first two is for B, and the next one is again for the B, and the last one is for I think F. Okay, and let's find out all the other mappings, because first we need to understand this problem in the depth. Okay, so the next valid mapping would be like keep first two as it is. We can group this one. Why we are going to group this one? You can see that if we are going to group this one, the number that is going to be formed is like 26. Okay, and the 26 is being denoted by Z. Okay, so you are going to say, yeah, I can group this 26 like this one. So what is the like a string that is formed with this one? You can see 2 is for B and 26 is for Z. Okay, can we have more mappings? Yeah, we can have also more mappings. How it is going to be done? You can group these 22 into a single one. So it will be like 22 followed by the rest one 6. Okay, so it can be like any character, I don't know. Let's Z it for 26. Okay, so X, Y, Z. So it is Y, Z, sorry, X, Y, Z, T, U, V, W. Okay, W, X, Y, Z, and U, and then T, U, V, W, X, Y, Z. So this is for 26, 25, 24, 23, and 22. Okay, so we would have like 22 is for V and 6 is for F. So VF is another possible decodings. Okay, so these are the three possible ways we can like separate form groups within these strings such that every group is a valid mapping as given in the problem statement. You need to find out the total number of ways to do that. Okay, so we are going to like use the dynamic programming to solve this problem. Why we are going to use the dynamic programming? Because the answer for current state, like let's say current character is being introduced right now, then the answer for the current state totally depends upon the previous character and the previous to previous character, right? Okay, that's why we are going to use the dynamic programming. How the characters dependencies I am talking about, let's try to understand this one in detail. Okay, so let's try to build the answer for this string. Okay, suppose that we are going to start with the very base case, like we have the only the very first string, sorry, only the very first character, that is the character 2. Let's discard the remaining strings for now. Suppose we are going to focus upon this only, that is we have the character only as this one. Now you can see that if we have only a single character, what is the number of ways to reach to have this string? You can see that number of ways to have this one is like only one. What is the only one way to do that? You can see that 2 has the mapping as B, right? So if we consider only this character, only a single character, we are going to do that. Yes, I am going to put B over here. Okay. Now let's introduce another character. Also we are going to use the DP, so why not to define something like that. Okay, so let's say we are going to have this linear array which is going to denote the answer. This is 0, this is the first position, this is the second position, this is the third position. Let's define the base case as 1, and we are going to talk about this position. So if it is only a single character, the answer would be like dp of I equal to dp of I minus 1. You can see that there is only one possible decodings, which is like for this 2 it is B. Okay, so for the first position I'm going to fill as dp of I equal to dp of I minus 1, which is 1. Okay, now let's move on to the answers for the rest of the cases. Now the character that is introduced now, that is dp of 2 I'm talking about, is this character. Okay, now the thing is like when you are encountering a new character, you can easily see that if this character is like 2, we have a mapping over this one, like 2 is being denoted by B. Okay, so if it has a valid mapping, then you are always going to have this relation dp of I equal to dp of I minus 1. Why we are going to have this relation? You can see the number of ways to reach up to this current state is exactly equal to the number of ways to reach up to the previous state, because the current like the current string, sorry, current substring of length 1, that is the 2 over here, can be grouped separately. Okay, so if it is grouped separately, what is the number of ways to reach up to this point, like up to this one? Okay, so it is exactly equal to dp of I minus 1. That's why number of ways to reach up to this point would be like dp of I exactly equal to dp of I minus 1. Okay, now there are more possible ways to reach up to this one. What are those more possible ways? Let's try to understand that. Okay, so you can see that I have talked about only a substring of length 1, right? So we can have this one also, 22. 22 is also a valid mapping, right? So dp of I is going to be like summed with number of ways to reach up to the previous position, dp of I minus 1 plus dp of I minus 2 for this current state. Okay, dp of I minus 2. Okay, now the thing is like this relation, this one does not hold every time. Why? You can see that I need to do this condition like number of ways to reach up to this point is equal to the sum of number of ways to reach up to this point plus the number of ways to reach up to this point, like considering these two characters, right? So this is not always valid. Okay, and when this is valid, you need to understand that when we are talking about a substring of length 2 ending up to this current position, you need to be very much careful that you are going to have all those characters like starting from 10, 11, 12, 13, 14, 15, 16, 17, and it goes up to 26 only. Okay, so if you are finding out the answer for this current state, you need to be very much careful that previous character must be like 1 or must be 2. If it is 1, this character can be anything starting from 0 up to 9, and if the previous character is 2, you are going to have 21, 22, and it goes up to like 26, right? So you need to check that this current character must be less than or equal to 6 1. Okay, so you are going to have a dp relation, right? If a current character is valid, you are going to say dp of I exactly equal to dp of I minus 1. If we are going to make a new group right now, that is, you can see here over 2, you are going to say yes, only group 2 can be made because 2 is a valid mapping and its mapping is of B. So we are going to say yes, it is valid mapping, dp of I equal to dp of I minus 1, and dp of I minus 2 term must be added only and only when the previous character, you can see that if you find out the number found from the previous character, it is like 10, 11, and it goes up to like 26, then only and only when we are going to add this term. Okay, now the tricky part is like when we have the new term introduced as, let's say 226, and let's say we have this 0. Now if we have a 0, we are not being able to group this one like into a separate, we are not going to group only 0 into a separate group, like we are not going to add this for dp of I equal to dp of I minus 1. Number of ways to reach up to this current state is not equal to the number of ways to reach up to the previous state, because we are not going to be able to group this 0 separately. Okay, because 0 is not a valid mapping, you can see over here. Okay, but we can introduce this term for the 0, like we can have 10, we can have 20. So for the case of 0, you need to check it out that previous character is either 1 or 2, then you are going to introduce only this term. This term will never be included when the ith character is 0, right? This term will be included when the ith character is 0 and the previous character is 1 or 2. Okay, so overall the general dp relation would be this one, dp of I equal to dp of I minus 1 plus dp of I minus 2, provided that the some like dp of I minus 2 will be included in some of the cases and dp of I minus 2 will be included in the some of the cases. Okay, now the thing is like this let's understand this entire thing while you are going to code it up, and you need to be very much careful to understand every corner cases. Okay, so let's move further to understand this thing in the coding part also, where I will explain how the things are happening and what are the corner cases that we need to maintain. Okay, so let's move further. Okay, so you can see over here, I've already runtime 0 ms and faster than 100% of CPP online submissions I have submitted over here. So let's discuss the code directly. So, okay, so what I've done is like I've defined a dynamic programming states where it is being denoted by a vector, linear vector, where base case is 1, dp of 0 is 1. Let's start exploring every ith character. If the ith character is 0, you can see this one, then the only possible case is like since the mapping of 0 is not present, then we need to check it out whether the previous character is 1 or 0, because you can see that mapping that is possible is 10 and 20. It has a valid mappings as given. Okay, so we need to check it out the previous character, that is I minus 2 must be existing, and it is either 1 or 0. Then the number of ways to reach up to this current state would be exactly equal to the dp of I minus 2 state. Okay, and what about when the ith character is not 0? Then number of ways would be like number of ways to reach up to the current state can be like it is equal to the number of ways to reaching up to the previous state, because we are going to group this current element separately. Like suppose we have this one, 2, 2, 6, and we need to check it out that what is the number of ways to reach up to this point. Okay, so we need to just add it out the number of ways to reach up to I minus 1, that is this box, because we are going to group this 6 separately right now. Okay, because 6 has a valid mapping, you can see, yeah, 8 beast up to z, 6 has a valid mapping. And you need to check it out one thing, that we can have a substring of length 2 also, like starting from 10, 11, 12, and it goes up to 26. So you need to check it out if I minus 2 existing and s of I minus 2 is not equal to 0, and the numerical form of this string, which is going to be denoted by sto of I of, you can see I have taken a substring of length 2 starting from I minus 2, it is less than 26. Yes, we can say that number of ways to reach up to this current state must be like dp of I minus 2 term must be added to this current state, which is like total number of ways to reach up to this current state. Okay, and finally return the dp of n, which is the number of ways to reach up to this nth state, which is actually our answer, number of ways to decode this particular encoded string. So if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and to subscribe to YouTube channel for latest updates. Thank you for watching this video.